All right, here we go. So we are talking about bonding. Okay, we're talking about bonding for this next unit. It won't be a super long unit, but you will use this for the rest of the year. Okay, this is quintessential chemistry. All right, chemical bonds. So remember, what we're really focused on now is compounds. So we've been focused on the periodic table, which is just elements, which is a single element. Okay, but now we're talking about compounds, which is when we put two or more elements together. So most of the stuff in the world is made from compounds or mixtures, which is a mixture of compounds or compounds and elements. Okay, all right. So a lot of this stuff is from your notes from your quizzes on Monday. So I'm just going to kind of go through and highlight some stuff. Octet rule, what octet sounds like what number? 8. So octet rule is just saying that the atoms want their valence shell full. Okay, so they want 8 valence electrons. All right. Chemical bond, the whole reason that chemical bonds are made is for stability. Okay, so those elements combine with each other because everybody wants to feel like a noble gas. I want to feel like my valence shell is full, so I'm going to hook up with this element from the other side of the table so that we can either share or transfer valence electrons. Okay, the whole reason we did a unit on just the electron is because when we do bonding, bonding has nothing to do with the nucleus, nothing to do with protons, nothing to do with neutrons. It is just your valence electrons. And where are our valence electrons? The outermost ring or the outermost shell, okay? So all those inner electrons don't change at all, okay? All right, so here we are at number 3. We're just talking about compounds, chemical combination of 2 or more elements. The properties are going to be different from the properties of the elements that make it up. So remember we talked about sodium chloride before. Remember sodium chloride was table salt, so that's Na. We're going to learn how to write this today and how to name it, but NaCl is the name for sodium chloride. This is table salt, what we eat on our food, but sodium by itself is a shiny metal. Remember I showed you guys that video of them chunking a piece of sodium in the pond and it exploding? And chlorine is like a yellow colored gas, okay? So thank goodness we're not eating something on our food that is a yellow gas that explodes and is shiny, okay? So together they make totally different properties. All right, your video notes from Monday talked about 3 different types of compounds. There was 3 different ways they could combine. One was metallic. Can somebody tell me what another one was? There's 2 other ones. No, that's a property for metallic, but there was sometimes valence electrons got shared and then sometimes they were transferred. One started with an I and one started with a C. Anybody got that for me? Covalent? Covalent, yes, covalent is one. And then the other one?
Ionic.
Ionic, excellent, ionic. Okay, so when we are talking, so today we're going to be focused on ionic, okay? We're going to focus on ionic, and that means that we're going to talk about what happens when we transfer electrons, okay? All right, so this is just talking about ionic and covalent and metallic. I'm not going to really go through this because you guys already have notes on this. This is just another set of notes. Valence electrons, we talked about those are the ones that are actually doing the bonding. You should know how to do your valence electrons for your groups, okay? And then let's talk about this just for a second. This was also in your notes, but I'll do a little bit of notes right here because there's some stuff that I do want you to get down, okay? Ion formation, okay? All right, so ion formation, that's what happens. You form an ion, okay? You form an ion when you either lose or gain electrons, okay? So an ion forms when you gain or lose electrons. So you're going to be gaining or losing, gain or lose electrons. And again, specifically, we're talking about our valence electrons. All right, does anybody remember the shortcut for knowing if you look at a cation, is this the positive ion or is this the negative ion?
Positive.
It is the positive. Do you remember the shortcut for how we know that?
No.
Okay, anybody know a shortcut? Excellent. The T looks like a plus sign. Okay, this looks like a plus sign. So this is the positive ion. Okay, cations are positive ions. Okay, now I want you to think about this. Remember, you cannot gain or lose protons, because if I gain or lose protons, it's going to change my element. Okay, so for me to have a positive ion, a positive charge, did I have to gain or lose electrons? Excellent. All right. So I had to lose electrons. So cations are positive ions. They happen when you lose electrons. Okay. They happen when you lose electrons. All right. Here's something else I want you to note. All right. Metals. All right. So that means left of the staircase, they always form cations. Okay. They are always giving up their electrons. They're always going to lose electrons. All right. So make sure you have this down. Cations, positive ions, that happens when you lose an electron, and that's what metals do. Okay. So that means we should have the exact opposite on the other side. Anion. Anybody remember how we know anion is the negative one, just besides the fact that it's the opposite? Anybody remember this one? Anion. Okay, this one, anion is the negative one. It is a negative ion. A negative ion. Okay, a negative ion. All right. So this should be the opposite of everything that we had on the other side. So this is anions are the negative ions. How do we make those? What do we need to do?
Gain electrons.
Excellent. We need to gain electrons. Gain electrons. And who do you think forms anions?
Non-metals.
Excellent. Somebody online, who's the opposite of a metal?
Non-metal.
Non-metals. Excellent. All right, so non-metals, all right, form anions. Non-metals form anions. Okay. Excellent. Yes, nice job, Brooklyn. All right, so we have cations, okay, which are positive, they lose electrons and they're metals, and then anions, which are negative ions, they gain electrons and they're non-metals. So remember, this all has to do with your valence electrons, okay, valence electrons. So just as a refresher, remember, like for instance, sodium is Na, he's in group 1, so how many valence electrons does he have? One valence electron, okay, he's in group 1. And remember, everybody wants to look like a noble gas. So sodium has 11 protons, okay, and 11 electrons. He's got one valence electron. He can either gain 7 more electrons and look like, let me just show you, let me share my screen. Give me 1 second. Let's see if I can. Actually, I'll just show you right here. All right, so here's sodium right here. Okay, I don't want to erase all my stuff yet. So here's sodium right here. All right, he can either gain 7 electrons and look like argon, or he can lose 1 electron and look like neon. What's the easiest thing to do? Is it easier to lose 1 electron or gain 7?
Lose one.
It's easiest to lose 1. Excellent. Okay. So because it's easiest to lose 1, okay. Let me see. Oh, here we go. All right. Because it's easiest to lose 1, when he loses that 1 electron, okay. Give me 1 second. Here we go. All right. So when he loses this 1 electron, instead of 11 electrons, now he has 10 electrons. Okay. But he still has 11 protons. This is why sodium forms a +1 charge, okay? And everybody in that family forms a +1 charge, okay? So if you know your valence electrons, remember if you got less than 4, you're gonna lose them, okay? So group 1 has 1 valence electron, they have a +1 charge. Group 2 has 2 valence electrons, they're gonna lose both of them, they're gonna have a +2 charge. Group 3, for the most part, they're gonna lose those 3, they're gonna end up with a +3 charge, all right? Once you get past the halfway point, you go the other way, okay? You go the other way. So you're gonna have, and I'm gonna show you guys a chart in a little bit, but you would start to gain electrons, which would give you a negative charge. So you have like a -3 charge or a -2 or a -1, okay? All right, so we talked about cations and anions. Transition metals are funky, okay? They're a little bit funky because they may lose more than 1 electron. They're kind of different. They have multiple charges, okay? So they have multiple charges. So that's the big thing to remember about them. And because of them, we're gonna focus on them another day because we have to name and write their formulas just a little bit different, okay? All right, so now that we have talked about, this one is just saying, this one down here would be chlorine. If I did the same example down here, this would be, I think chlorine 17, isn't it? Yes. 17 protons, 17 electrons. And on this one, he's a halogen, so he's right next to the noble gases. So he just needs 1 more electron. So he would take 1 more, so he would have 18 electrons. Still 17 protons, and that's how he ends up with a -1 charge, okay? All right, so that is cations and anions, just a brief refresher, okay? All right. So let's clear this. Hopefully, as long as you got the anion, cation stuff up here, you should be okay, okay? All right. So now, let's move on. All right, so what we're going to be talking about today is the ionic bond, okay? So I'm going to switch over to this flow sheet that I want, or this flow chart that I want you guys to look at. This is on OneNote and it is on Schoology. I would strongly suggest you open it, okay? I would strongly suggest you open it, all right? You're going to need it because you're going to want to look at this table a little bit later, but we're going to start on this front side, okay? There's a lot of information on here. We're going to ignore a lot of it to start, okay? Because I'm going to teach you how to name and how to write formulas in small clusters, okay? And we'll focus on 1 cluster at a time, and then we'll learn another cluster, then we'll learn another one, and then we're gonna start mixing them all together, and then you're gonna get super confused, but then you're gonna practice, and it's gonna be great, and you're gonna figure it out, okay? All right, so let's talk about how to name them, okay? So when we see stuff like, you know, when we see names like this, sodium oxide, nitrogen dioxide, carbon oxide, sodium sulfate, aluminum oxide, iron 2 chloride, that's what we're about to learn how to do, okay? And then we're also going to turn around and learn how to write formulas. What do these little numbers mean? How do we put these together? Why do we need parentheses? That's what we're going to be learning. So today we're going to start really, really simple. I do want you to have your periodic table nearby, okay? And remember, I'm going to call on everyone. I want you to have your periodic table nearby, especially if you're still rusty on knowing your elements, okay? All right, here we go. I'm going to try to make this a little bit bigger so you can read it. There we go. All right. Here's the first thing I want to talk about, okay? We want to know if something is ionic or covalent, okay? When we're talking about whether it's ionic or covalent, we're going to be focusing today on just the ionic side, okay? If you have an ionic bond, does anybody know, does that mean did you transfer electrons or did you share electrons?
Transfer.
Excellent, thank you, James. That means that we are transferring electrons. That means somebody's going, I don't want these anyway, you can have them. And somebody's going, oh my gosh, that's exactly how many I needed. Thank you so much. Okay, so this is transfer of electrons. Okay, transfer of electrons. All right. Now, for today, we're not looking at covalent. We're not looking at any of the stuff on this side. So do not even look at this side because it will throw you off. Okay. All right. So the first thing is, when you are naming something, the first thing you have to ask yourself is it ionic or covalent? Okay. Here is how you know it's ionic. Okay. If you see a metal and a non-metal, then it is ionic. Okay. A bond between a metal and a non-metal means you have an ionic bond. Okay. Somebody is willing to give up electrons and somebody is willing to take them. Okay. We're also going to learn, not today, but you can also have a metal and a polyatomic or two polyatomics. Okay. All right. So here's how we're going to do this. Okay. I'm going to cross out some stuff because I want you to, I want to start off slow. Okay. So this is our first cluster. When we are naming a compound, when we're naming a compound, okay, if there are two elements, okay, if there are two elements, you're going to name the first element, okay, forget all this, okay, and then your second element is going to end in IDE, okay, your second element is going to end in IDE. Name your first element, and then your second element, you're going to change the ending to I, okay? Now remember, it's always going to be, and in this order, a metal followed by a non-metal, okay? A metal followed by a non-metal, okay? And when we're talking about metals, we're not going to get into the transitions just yet. We're not going to get into those just yet, okay? So for example, okay, I'll give you the first one, okay? And this is one we've done a zillion times. I could say, what is the name of this? NaCl, okay? Na. Can somebody tell me? So the first thing it says, name the first element. Okay, so let me erase. All right. Oops. So it says the first thing we need to do is name the first element. Name the first element. So what is the name of that first element? Sodium, right? Everybody agree with that? The first element is sodium. Let me just go through this again because I don't want you guys to read this just yet. All right, so name the first element, and then the second element we're going to end in I. So Kay said the first element here is sodium, and he is correct. All right, somebody tell me what the second element is though. It's chlorine, but we're going to change the ending to ide. Okay, so instead of chlorine, we're going to say chloride. Ide. That is the name of this compound. Sodium chloride. Sodium chloride. Okay, seems pretty easy, right? Have I said anything about numbers? I have not. So even if I start writing stuff and I have numbers, we're still using the same rules. We're not going to do anything different. Okay, we're not going to do anything different. So for example, what about if I gave you this? Okay, there's a number there. It doesn't matter. You're still using the same rules. Okay, so let me give everybody a chance first. Okay, you're still using the same rules. So I want you to do the same thing I still said. Okay, there's nothing different. You're going to name your first element. Okay, and then your second element, we're going to change the ending to I. We're going to change the ending to I. Okay. All right. So, Brooklyn, can you tell me the name of that first element? there, Brooklyn?
In chat.
Oh, she's in the chat. I want to know what what element that is, Brooklyn. That's what I'm asking you. Give me 1 second.
Lithium.
Thank you, Charlie. It is lithium. Let me make this one go. I guess she's just private chat. All right, thank you, Charlie. It is lithium. Okay, so the name of this is lithium. And then can somebody tell me the name of the second element? It is sulfur, okay? So Elizabeth said the name of the second element is sulfur. All right, so this one's kind of weird because what do you guys think it is? We need to change the ending to I.
Sulfide. Maybe, I don't know.
Fantastic. No, that's right. That's exactly right. It is sulfide. Sometimes people say sulfuride or so whatever. Yeah, it's kind of weird. But this is sulfide. So this is lithium sulfide. Excellent. Okay. Lithium sulfide. That's the name of that. All right, let me give you another one. How about, ooh. Okay. All right, so we got another one here. All right, remember you name your first element and then your second one. This one's also kind of weird with the ending. Okay, it's also kind of weird, but that's okay. I want us to get through the endings of most of the anions. Okay. All right. Ariane, are you there? Are you there, Ariane? No. All right, Melissa, are you there?
Yeah, I'm here.
Okay, can you tell me what element is Ca?
Calcium.
Excellent, it is calcium. All right, so this is calcium. Is it changing? Ugh. All right, so this is calcium, Calcium. All right, this one, somebody tell me just tell me what the second element is. It is phosphorus, very nice. All right, so this one's kind of weird. A lot of people say phosphoride, okay? So but we're gonna drop the R completely. This one's gonna be phosphide, okay? Now, let me just clarify, if you wrote on here, if you wrote phosphoride, until we get used to it, I would still take that, okay? But it is phosphide, calcium phosphide. All right, let's do one more. And then we'll go on to how to write formulas. All right, let's do. All right, I'm going to come over here to this side because I'm running out of room. All right, take a second. You can try to hit me in the chat and tell me what you think it is as well. One. It is an AL, AL.
Is it aluminum?
Aluminum is the first element. That's correct, Gibson. So the first element is aluminum. All right. Angel, you want to try for the James? That is excellent, correct? Angel, you want to try the ending? What do you think? Are you there, Angel?
Yeah, I'm here. Is it bromine?
Bromide, excellent. Aluminum bromide, that's the name of this. Oops, let's change this color. Bromide, aluminum bromide, excellent. All right, so far so good, yes? These make sense? These are pretty easy so far, right? All right, so let's talk about, sometimes I was writing numbers, sometimes I wasn't, okay? So let's talk about why sometimes I wrote these numbers and why sometimes I didn't. So I'm gonna scroll down to the next page, okay? If you got your Chem Cruncher open, that would be excellent. But also, I'll try to zoom in. I want you to be able to see this chart at the bottom that has the charges, okay? All right, so let me scroll down. I hate how this is scrolling, but it's not actually going anywhere. Excellent. Look at my bar scrolling, but it's not going anywhere. Okay. Let me try. There we go, finally. All right. Oh, my goodness. All right, here we go. So now let's talk about why those numbers were important, okay, or what they even represent. All right, so we're still focused on the ionic side, okay, so we're not going to be looking at anything that has to do with this stuff over here, okay, nothing with covalent. All right, we're going to focus on just this, and for right now, we're only going to focus on this box right here, okay. All right, so now let's say that I had given you, let's talk about the last one we just did. So we just did aluminum bromide. That's what we just had, okay, aluminum bromide. All right, so again, the first thing I do is, when I'm trying to figure out how to write a formula, the first thing I'm going to ask myself is it ionic or covalent, okay? Well, let me tell you how I know this is ionic, okay? Because I know that this bromine is a non-metal, and I know that this aluminum is a metal. And anytime I see a metal and a non-metal together, it is ionic, okay? So that's the first thing. So in this case, you don't have to ask yourself that because we're going to be doing all ionic right now, okay? Now, this says here that if we have a metal and a non-metal, or polyatomic, which we'll get to in a second, okay, we must get the charges to be equal to 0, okay? We must get the charges to be equal to 0. This is only for ionic, okay? Only for ionic, all right? And to do that, we need to use subscripts to determine how many ions it takes, okay? And what that means is, if you see me write something, for example, just writing something random, H2O, okay, H2O. This 2 is a subscript. It's a small number. It sits low, and that means that I have 2 of those hydrogens, okay? That's all that's telling me, okay? So the subscripts tell me how many I have, so that's what that means. So let's talk about aluminum bromide. So let's walk through how we do this. All right, if I want to write the formula for aluminum bromide, the first thing I need are the symbols, okay? And the symbols are the ones that come off the periodic table, all right? So we had kind of just did this one just a few minutes ago. Can somebody tell me the symbol for aluminum? And when I say symbol, I mean the letters. Excellent. Elizabeth says AL. She is correct. All right. All right, and then can somebody tell me, Mandy, can you tell me the symbol for bromine?
BR.
BR, excellent. All right. So now we have the symbols for aluminum and the symbols for bromine, okay? The next thing we have to do is get our charges, okay? Our charges. So if you don't know, if you have your valence electrons written on your periodic table on your personal chem cruncher, it may be a good idea to write your charges as well, okay? And my charges are right here. Let me just show you. Good job, Brooklyn. I just saw yours too, okay? Here are the charges down here, okay? At some point, you definitely want to try to start to memorize these as well, but they're down here, okay? All right, so, Anthony, can you find aluminum and tell me what the charge for aluminum is? And then Louise, can you find bromine and tell me what the charge is for bromine? Yes, can you find aluminum down here? So, because we're looking for aluminum, and tell me what the charge is, what the yellow number is for aluminum. Luis, are you there? Very nice. Anthony says in the chat, he said +3. Luis, are you there? All right. So Anthony's right. The aluminum is +3. +3. And then let's see. Chloe, how about bromine? Can you find bromine and tell me the charge for bromine? You there, Chloe? It is negative. Can you tell me the number? Negative what? I'm just looking in the chat. She's talking to me in the chat. What number is next to the negative? You are right, it's negative. And so it's right down here on this chart, on this periodic table at the bottom. Can somebody help Chloe out? Negative what? It is -1. So when I look at bromine, it's right here, Br, and it's in the column for -1. Okay. All right. So bromine is -1. Now, remember the whole point is for these charges to be equal to 0. If I add these charges up right now, will they equal 0?
No.
No, they won't. It's -3 plus negative, I'm sorry, +3 plus -1. That's going to come out to like +2, okay? I need them to come out to 0. So I can either add some more aluminums that have a +3 charge, or I can add some more bromines that have a -1 charge. Maybe I can add both, but you know, what do you guys think we need to do in order to get it to a 0 charge?
Add more bromine.
All right, so I'm gonna add more bromine. So let's see if I add, here's another bromine. All right, did that get us to 0 yet?
No.
No. All right, let's add one more. All right, would that get us to 0?
Yes.
Yes, it would. All right, so that's +3. And then these 3 minus 1s would be a -3. That would get us to 0. So in other words, what I need in order to write this formula, I need 1 aluminum. I don't have to write the 1 because it's understood, okay? And then I need 3 bromines. So I'm going to write a Br, and I'm going to say that I need 3 of them. This is the formula for aluminum bromide. Okay, that is your formula for aluminum bromide. Okay, so that's the process that we'll go through. if you can do this part in your head, fantastic. If you can't do it in your head yet, that doesn't mean you won't be able to do it at some point. However you need, wherever your comfort level is, okay? So let's do another one. How about, all right, here we go. See if you can follow the same process. I want you to put it in the chat. Tell me what you think the formula will be. Okay, you're gonna put it in the chat and tell me what you think the formula will be. I'll give you like 3 minutes. See if you can figure it out. All right, Charlie, can you tell me at least the symbol for potassium? And then
Okay.
what is it?
You said the symbol for potassium, right?
Yes.
Okay.
Okay, excellent. And then Gibson, how about the symbol for oxide, which comes from what element?
Oxygen.
Oxygen. What's the symbol for that? The letter.
O.
All right, so now I need my charges for both of these. Anybody got my charges for these? Okay. Elizabeth told me potassium is +1. Can somebody online give me oxygen?
-2.
Excellent. I heard 2 people say that. Great. -2. All right, -2. Oops, I forgot to write my 1 for this one. All right, so remember, we have to get this to be equal to 0. I can either add more potassiums or more oxygens. Right now, it is not equal to 0. Okay, so it can't be just KO because right now they're not equal. So what do I need? More potassiums or more oxygens? More potassium. Let's try to add 1 more potassium and see if that works. Here's another K with another +1. +1 +1 and a -2, is that 0? Yes, it is. So that must be my formula. So remember when I write it, okay, I'm going to say, okay, there's K. I had 2 of them. So the 2 goes behind the K because it's 2 Ks. And then O, okay? And I don't have to write the 1s because they're understood. So this one is K2O, K2O. All right, K2O. All right, let's do another one, and then I'm gonna give you guys kind of an exit ticket, and we'll be done. We're gonna do a lot of practice on these, okay? Because this is just small cluster, but then we're gonna get a little bit harder. All right, how about I'll give you 2 of these. So here's number 1. Here's number 2. This one is calcium nitride for 1. And then how about all right, there are your 2, calcium nitride and strontium sulfide. See if you can figure those out. Okay. I'll give you a couple of minutes. So remember, you can write out your charges to start. Write it out like I did. So write your symbols, write your charges over your symbols, see if it equals 0. If it doesn't equal 0, get them to equal 0. And then whatever, like mine in the black box, that's your final answer. All right. Let's see. All right, Angel, I would like to answer the number 1, and Melissa, you can give me the answer to number 2. Angel, are you there?
Yeah, I'm here.
Okay. For number 1, what'd you get? Melissa, are you there?
Yeah, I'm here, but I'm still trying to solve it.
Okay. Here we go. Let's do a whiteboard 5. I'll do this one for a grade. All right. So I'll tell you the answers to these, and we're going to do 2 more. And we're going to do them for a grade because nobody wanted to write me in the chat. All right. So for this one, you should have had Ca, which has a +2 charge. N has a -3 charge. We had to find a least common multiple between them, which is what? Least common multiple between these two. That's so that we can get them to 0. 6. So that means we need to get the CAs to a +6 and the N's to a -6. So you probably needed another N and you needed 2 more CAs. So you need another CA here and another CA here. So this one should have been Ca3N2. All right, strontium sulfide, that one worked out pretty good. Strontium is Sr. Sulfide came from sulfur. What's the symbol for sulfur? S. And this was a +2. This was a -2. So that was the answer. You didn't have to put anything. SRS. All right, so let's do a whiteboard 5. I'm going to do naming and formula writing.